Hi, welcome back to the channel. So in this video, we will see the derivation for integrator, which will come in the concept of op-amp. We consider it as op-amp configuration or the integrator. So first, draw the circuit diagram. How we should draw the circuit diagram is, first is always the op-amp, which is minus, plus, and it is output and it is input. For the input, you should connect resistance and feedback. For the feedback path, it is having for an integrator, we will be having a capacitor and it is output. This is grounded. This is point B, so we will call it as point A. This is the resistance R and this is the feedback capacitance CF, right? So for this, input is applied, right? So anything is missed out, so obviously you will be having 5 terminals, so it is plus V and it is minus V, right? So we should derive the output expression. What is going to be the output expression for the integrator? So for that, we will take the help of virtual ground concept. Node B is grounded, hence from the concept of virtual ground, node A is also at ground potential. So VA is equals to VB is equals to 0. So that is the first thing, right? Then after that, we should write equation for a current at input side. So input side means this side, right? At node A, we will write what is going to be a current I. So the current I means here it is going from this place to this place. That is from through the resistance. Then later it is going to like this, right? So input side, what is the current I? Current I can be written as input voltage is V in minus what is A voltage, VA divided by R, right? So now what is VA value? 0. So that we can write this as V in divided by R. Call this as equation number 1. Now we have written input. So we should write what is the current equation for the output side. So same, we will consider this output side. Current I is, so here we can write VA minus V output, as like we have done in inverting and non-inverting. But here I can't write the Ohm's law. There is a one thing is extra is here. What is there? Ohm's law. Here we have written I equal to V by R, but here it is. What is there? Capacitance is there. For this, we should know what is the relationship between current and capacitance. I is equals to C. D by dt of V is there. So this is what the expression. With the help of this expression, we should write this. So I is equals to C. What is C? CF, capacitance, feedback capacitance, d by dt of V. What is V in this case? VA minus V output. What is the value of VA? 0. So I is equals to CF d by dt V output and it is minus. You will be having minus for this. So I is equals to minus. So I will write this as equation number 2. So equate equation number 1 with 2 because we are applying Kirchhoff current law at node A, right? So at node A, current entering is I and the current leaving is I. So the equation number 1 is equal to equation number 2. What is the equation number 1? V in divided by R. What is the equation number 2? RHS, LHS are equal. So RHS CF d by dt of V output, right? So now I want this V output, right? So here what we can do is we can write as d by dt of V output is equals to, you can push this 1 divided by CF into R multiplied by V in, you will get. What you should get now? Integration. This is an integration circuit. So here I want output, so that what you should do is integrate both sides, right? If I integrate this, what you will get? Integrated and differentiation will get cancelled. V output is equals to minus constant R into CF integration of V in dt, you will get from 0 to t. So this is what the integration circuit with respect, integration output expression with respect to this integrator op-amp, right? So here, apart from this, we can write some of the equations, some of the waveforms. So how to draw the waveforms, that we will see now. Not exactly the procedure. We'll see suppose if the input is sine wave, what is the output? Output is cos. What is the integration of sine? It is cos. So here, suppose the input is sine like this. What is the output? Output is going to be cos t. So it is sine and it is cos. Assume that the input is going to be something like step function. At that time we will get a ramp if I use the integrator. Suppose the input is going to be a square, so you will get a triangle shape waveform, right? So for this we will be having a procedure, but you should know if is sine cos sine, step ramp and square and triangle, right? So this is a integrator. So similarly we can consider the differentiator. So how to consider the differentiator, right? So we'll see that. Same circuit diagram, only thing is you should interchange the capacitor as well as the resistor. So everything else is same. So we'll see that. So that most of the time they will give this integrator as well as the differentiator concepts, right? So we'll see that. So if I want to draw an integrator and differentiator, so we'll consider now differentiator. Using op-amp. So same, consider op-amp, right? So here input we will consider capacitor, feedback we will consider resistor. It is output, right? So this is same, it is grounded. This is point B and this is point A. Here it is input through which the current I flows, so it is C. Same current I flows, which is which is R, and it is feedback resistance. It is plus, right? Same. From the concept of virtual ground, node B is grounded, hence node A is also grounded. So VB equal to VA equal to 0. And now we should write the current equation for the input side. What is the current which is flowing through the capacitor? I is equals to, we know that I is equals to C multiplied by d by dt of V. This is the equation relation between I and C. So we will write I is equals to C d by dt of, what is that? V in minus VA. So we will write this as V in minus VA. What is the value of VA? 0. So this part is 0, means I is equals to C multiplied by d by dt of V in, I will get, this is equation number 1, right? So if I write what is the equation for output side, suppose if I consider this is the output side, so I will make a demarcation line. This is input and this is output. I want to write what is the current which is flowing through this resistance, VA minus V output divided R. It's a Ohm's law. I is equals to V by R, right? VA is 0. This part is 0 because of virtual ground concept. So V out divided by RF, you will get it, right? So I will call this as equation number 2. Next, what I will make is, I will make equation number 2 equal to 3. So here what you will get is minus V output divided by RF is equals to C multiplied by d by dt of V in, I will get it, right? So since it is a differentiator part, d by dt of V in, suppose I want V output, how we can write? Minus C into RF multiplied by d by dt of V in, I will get it, right? So this is what a differentiator output expression, right? Suppose if the input is going to be a sine wave, what is the differentiation of sine wave? It is going to be a cos wave. If it is a differentiation is cos, it is minus sine, right? That you can give the output expression for differentiator. So integrator and differentiator, only you should interchange this. Apart from that, everything is else